Welcome to our channel. Today, we're diving into the wonders of space with some truly fascinating facts that will blow your mind. Have you ever wondered about the vastness of space? The sheer scale of the cosmos is almost beyond human comprehension. Imagine, if you will, a time before our planet, before our sun, before even the concept of time as we know it existed. Picture a universe devoid of galaxies, stars, and planets, a blank canvas waiting to be painted with the wonders of creation. About 13.8 billion years ago, the universe we know burst forth from an infinitesimally small point in a cataclysmic expansion we call the Big Bang. This monumental event set the stage for everything we see around us today. Now here's the kicker: the universe isn't just expanding, it's accelerating. This means that galaxies are not only moving away from each other, but they're doing so at an ever-increasing speed. Back in the 1920s, Edwin Hubble observed that galaxies are moving away from each other, a groundbreaking discovery that changed our understanding of the cosmos, and the farther away they are, the faster they're receding. This observation led to the realization that the universe is expanding uniformly. It's like baking a loaf of raisin bread. As the bread rises, the raisins move apart. This simple analogy helps us grasp the complex nature of cosmic expansion. Scientists have attributed this acceleration to a mysterious force called dark energy. This enigmatic force makes up about 70% of the universe's total energy content. It's like a cosmic anti-gravity, pushing everything apart, leading to an ever-accelerating expansion. This discovery has profound implications for the ultimate fate of the universe, suggesting it will continue to expand indefinitely. Let's talk about black holes, those cosmic monsters that have fascinated scientists and stargazers alike for decades. These mysterious entities lurk in the depths of space, hidden from direct view but revealing their presence through their powerful gravitational effects. These aren't just holes in space, they're regions where gravity is so strong, so intense, that nothing, not even light, can escape their grasp. The boundary around a black hole, known as the event horizon, marks the point of no return. Imagine the entire mass of our sun squeezed into a sphere just a few miles across. This gives you an idea of the incredible density and gravitational pull of a black hole. When massive stars reach the end of their lives, they explode in a spectacular supernova, releasing vast amounts of energy. If the star's core is massive enough, it collapses in on itself, creating a black hole. This process is one of the most violent and energetic events in the universe. Black holes play a crucial role in the evolution of galaxies, their immense gravity sculpting the distribution of stars and gas. They act as cosmic architects, influencing the formation and growth of galaxies over billions of years. Supermassive black holes, millions or even billions of times the mass of our sun, reside at the centers of most galaxies, including our own Milky Way. These colossal giants are thought to have formed early in the universe's history, and have grown by consuming stars and gas, shaping the very structure of the cosmos. Now let's journey to the coldest known place in the universe, the Boomerang Nebula. This cosmic refrigerator, located some 5,000 light-years away, is a chilling minus 458 degrees Fahrenheit, just a degree above absolute zero. As the star at the center of the Boomerang Nebula sheds its outer layers, it expels gas and dust outward, creating this breathtaking spectacle. Think of it like a cosmic air conditioner. The expanding gas rapidly cools as it spreads out. By observing how this nebula forms and evolves, scientists can gain insights into the processes that govern the death of stars. Ever wished you had more time? In space, time itself can be stretched and warped thanks to Einstein's theory of general relativity. Time isn't absolute, it's relative, meaning it can flow at different rates depending on your relative motion and the strength of the gravitational field you're in. Astronauts aboard the International Space Station experience time slightly slower than us on Earth. Imagine approaching a black hole, a region of extreme gravity. As you get closer, time slows down exponentially. From an outside observer's perspective, you would appear to freeze in time at the edge of the black hole's event horizon. Time dilation is a mind-bending concept, a testament to the bizarre and counterintuitive nature of the universe. Our galaxy, the Milky Way, is hurtling through space at a staggering 1.3 million miles per hour. It's being pulled towards a mysterious gravitational anomaly known as the Great Attractor. This cosmic behemoth, located about 150 million light-years away, exerts a powerful gravitational pull on our galaxy and others in our cosmic neighborhood. It's hidden from our view by the plane of our own galaxy, obscured by gas and dust. Based on its gravitational influence, astronomers believe it could be a massive supercluster of galaxies. The universe is vast, teeming with billions of stars and potentially trillions of planets. So, where are all the aliens? That, my friends, is the Fermi paradox. The paradox highlights the apparent contradiction between the high probability of extraterrestrial life and the lack of contact with such civilizations. Some suggest that we are alone, that intelligent life is exceedingly rare in the universe. Others propose that advanced civilizations may exist, but are intentionally hiding from us, or that interstellar travel is simply too difficult. Water, the elixir of life, isn't unique to Earth. It's surprisingly abundant throughout the solar system and beyond. Take Jupiter's moon Europa, for example. This icy world harbors a subsurface ocean thought to contain more water than all the oceans on Earth combined. Enceladus, a moon of Saturn, has geysers that spew plumes of water vapor and organic molecules into space. These celestial bodies have sparked intense scientific interest because where there's water, there could be life. The discovery of water in these unexpected places has fueled the hope that we may not be alone in the universe. The universe is mind-bogglingly vast, but the part we can see, the observable universe, is just the tip of the cosmic iceberg. This observable universe is a small fraction of the entire cosmos, limited by the speed of light and the age of the universe itself. Imagine standing on a ship in the middle of the ocean. You can see a certain distance to the horizon, but beyond that, the Earth curves away. Similarly, our view of the universe is limited by the cosmic horizon, beyond which we cannot see. The observable universe is kind of like that. It's a sphere with Earth at its center, encompassing all the light that has had time to reach us since the Big Bang. This light has traveled for billions of years, painting a picture of the universe's history. The radius of this sphere is about 46.5 billion light-years. This means that the light we see today from the farthest objects has been traveling for 13.8 billion years. But due to the expansion of the universe, those objects are now much farther away. But the universe is expanding, and it's been expanding for billions of years. This expansion stretches the fabric of space itself, causing galaxies to move away from each other over time. The light from distant objects has been stretched out, or redshifted, as it travels through this expanding space. This redshift is a key piece of evidence for the expanding universe, showing us how space itself is growing. Astronomers estimate that the diameter of the entire universe, including the parts we can't see, could be trillions of light-years or even infinite. This suggests that the universe is far larger than what we can observe, with regions beyond our cosmic horizon that remain forever out of reach. Imagine peering back in time almost to the very beginning of the universe. Astronomers can do just that by studying the faint afterglow of the Big Bang, a cosmic relic known as the cosmic microwave background radiation, or CMB. This faint microwave radiation provides a snapshot of the universe as it was just 380,000 years after the Big Bang. The CMB is remarkably uniform, with tiny fluctuations that represent the seeds of the large-scale structures we see in the universe today. By studying these fluctuations, astronomers have learned a great deal about the early universe, its composition, and its evolution. In the vacuum of space, no one can hear you scream. That's because sound, unlike light, needs a medium to travel through, like air or water. On Earth, when we speak, our vocal cords vibrate, creating sound waves that travel through the air to our ears. But in space, there's no air, no medium for sound waves to propagate through. To communicate in space, astronauts use radios which transmit information via electromagnetic waves. Unlike sound waves, electromagnetic waves can travel through the vacuum of space. We're living in a golden age of space exploration, with new discoveries and advancements happening all the time. Take NASA's Artemis program, for example. This ambitious program aims to land the first woman and the next man on the moon by 2024. The James Webb Space Telescope, the largest and most powerful space telescope ever built, will allow us to peer farther back in time than ever before. Private companies like SpaceX and Blue Origin are also making significant strides in space exploration. They're developing reusable rockets and spacecraft that are making space travel more affordable and accessible. We're on the cusp of a new era of space exploration, one that promises to revolutionize our understanding of the universe. When it comes to space exploration, it's not just about the big, expensive missions. Small satellites, often the size of a loaf of bread or a suitcase, are playing an increasingly important role in our quest to understand the cosmos. These miniaturized spacecraft, often called CubeSats, are relatively inexpensive to build and launch. They're being used to study Earth's climate, track wildlife populations, monitor natural disasters, and even explore other planets. The rise of small satellites is democratizing space exploration, giving universities, research institutions, and even private citizens the opportunity to participate in the exploration of the final frontier. Thanks for joining us on this cosmic journey. If you enjoyed these fascinating facts about space, don't forget to like, subscribe, and hit the bell icon for more exciting content. Leave a comment with your favorite space fact, and let us know what you'd like to learn about next. Keep exploring, and we'll see you in the next video.